Dear students, in this video, we are going to study about AC circuits. What are the properties used in AC circuits or basic definitions used in AC circuits? First of all, what is the difference between alternating current and DC current? The first two units. First two units means basic DC networks and DC theorems. These first two units completely belong to DC supply or DC current. From third unit onwards, AC circuits. What is the difference between AC current and DC current? Alternating current is nothing but AC current. AC current is the current which constantly changes its amplitude as well as direction, reverses the direction at regular interval of time or periodically. So alternating current is the current which constantly changes its amplitude as well as direction at regular interval of time. This is nothing but AC current. Whereas DC current which consistently flows in only one direction, or unidirectional current. This is the main difference between AC current and DC current. Here we can observe the DC current. X-axis is taken as time, Y-axis is taken as either voltage or current. Voltage or current. So DC current consistently flows in only one direction, whereas AC current which constantly changes its magnitude and reverses the direction at regular interval of time. So because the changes are so regular, alternating voltage or current have a number of properties associated with any such a waveform. So first of all, we should go through the what are the properties or basic definitions regarding to AC circuits. First definition is alternating voltage. What is AC voltage? AC voltage is the voltage which varies its magnitude as well as polarity periodically. So same definition. AC voltage is the voltage which varies its magnitude as well as polarity at regular interval of time. AC voltage basically it is represented by small v equals to Vm sin omega t. So why? Because AC signal is always represented with sine wave. It is sinusoidally varying. This is the AC voltage. Constantly changes its magnitude and also reverses the polarity. These are the positive values. These are the negative magnitude. So its magnitude is constantly changing and the polarity is also changing. This is the negative values. These are the positive values. Similarly, alternating current is the current flowing in a conductor in magnitude. When the current flowing in the circuit varies in magnitude as well as in the direction periodically is also called alternating current. Alternating current is the current which is same, which constantly changes its magnitude as well as direction at regular interval of time. It is also represented by Im sin omega t. Im sin omega t. Im is nothing but maximum value. The signal is changing from 0 to maximum positive value and reaching to zero value and then reaching to from 0 to negative maximum, then reaching to zero value. So the signal is tracing from 0 to positive maximum, 0 and negative maximum and 0. So sinusoidally varying. So that the AC signal, AC current is also represented by Im sin omega t. Next definition is waveform. The shape of curve is obtained by, this is the shape. The shape of curve is obtained by plotting the instantaneous values of voltage or current against time is called waveform or wave shape. So it is obtained by plotting the instantaneous value. So first of all we should know about what is instantaneous value. So the plot is obtained by instantaneous values against time. This is the maximum value. This is the one alternation. What alternation means? One positive half cycle is nothing but one alternation. This is time period. This is the completion of one cycle. Complete one cycle. One cycle is nothing but one complete set of positive and negative values of alternating quantity is called cycle. One complete set of positive and negative values of alternating quantity is nothing but either voltage or current is called cycle. During one cycle, the waveform tracing from 0 to positive maximum, then 0, negative maximum, then 0. One cycle span is 360 degrees or 2 pi radians. So one cycle span is, this is 2 pi radians or 360 degrees equal to. And the next definition is frequency. What is frequency? The number of cycles made in 1 second is called frequency of alternating quantity. It is denoted by F. Frequency also defined as it is reciprocal of time period. F equals to 1 by T and unit is hertz and measured in cycles per second. The standard power supply of frequency equals to the standard frequency of power supply in India equals to 50 hertz. 50 Hz, whereas USA 60 Hz. There they are using 60 Hz. Here we are using India 50 Hz. Next definition is time period. The time taken for one cycle is known as time period. The time taken for completion of one cycle is called time period. It is also represented as reciprocal of frequency. T equals to 1 by F and measured in seconds. And the next one is angular frequency. Angular frequency, it is defined as a ratio of variation in angle in one cycle to time taken to completion of cycle. It is also defined as number of radians occurred in 1 second. Number of radians occurred in 1 second is called angular frequency. There 2 pi radians covered in one cycle. There are F cycles are occurring in 1 second. So 2 pi into F. F is nothing but 1 by T. 2 pi F radians per second or 2 pi by T. Next one, instantaneous value. The value of voltage or current at a particular instant of time is nothing but instantaneous value. The value of voltage or current at any instant of time or particular instant of time is nothing but instantaneous value. The instantaneous values are represented with a small alphabet. Here we can observe the instantaneous value. This is the instantaneous value 1, 2, 3, I1, I2, I3, I4 and so on like that. This is the instantaneous value at this particular instant. This instantaneous value of voltage or current at this instant. Like this, similarly, these are the instantaneous values. So instantaneous values are represented with small alphabets. So one cycle span is 360 degrees or 2 pi radians. Time required to completion of one cycle is nothing but time period. Frequency is also defined as reciprocal of time period. Next one, peak value. What is peak value or maximum value? Peak value or maximum value. The maximum amplitude of instantaneous value is known as peak value. The maximum instantaneous value of alternating quantity. This is the maximum instantaneous value. The waveform is changing from 0 to maximum value. 0 to maximum value. This is the maximum instantaneous value. Is nothing but peak value or amplitude or crest value. This is denoted by Im or Vm. Im or Vm. If it is voltage signal Vm, if it is current signal Im. Next one is peak to peak value. The maximum variation between the maximum positive instantaneous value. The maximum variation between the maximum positive instantaneous value and the negative maximum instantaneous value is nothing but peak to peak value. So for pure sinusoidal signal, the peak to peak value is 2 Vm. This is the Vm from 0 to positive maximum Vm, from 0 to negative maximum minus Vm. So this is for pure sinusoidal waveform 2 Vm or 2 Im. Peak to peak value is. Next one is phase. Phase is also defined as the angular measure of alternating quantity is called phase. The angular measure of alternating quantity is called phase. In phase means when two alternating quantities is nothing but two voltage signals. This is the voltage signal 1, this is the voltage signal 2, V1 and V2, namely reaching their maximum and minimum values, simultaneously, then these quantities are called in phase. Then these quantities are said to be in phase. Next one is out of phase. Here we can observe the in phase, reaching their maximum value and minimum value at a time simultaneously is nothing but in phase. Next one is out of phase. When two alternating quantities do not attain their maximum and minimum value simultaneously, then these signals are out of phase. This is also known as phase difference. This is also known as phase difference. This is the voltage signal 1. This is the voltage signal 2. This signal is starting from 0 angle. This signal is starting at 90 degrees. Let us assume 90 degrees. This is when two alternating quantities reaching their maximum and minimum values do not reach their maximum and minimum values simultaneously. So voltage signal V1 is reaching at maximum value is at 90 degrees. Let us assume voltage signal V2 is starting from 90 degrees. So do not reaching their maximum and minimum value simultaneously. This is nothing but out of phase or phase difference. The phase angle or phase difference. It is angular displacement between the two alternating quantities is called phase angle or phase difference. It is represented by Greek letter theta or pi. This is the phase difference between the two signals. Phase angle between the two signals. These two signals are in out of phase. They are not reaching their maximum and minimum values simultaneously. Do not reaching their maximum and minimum values simultaneously. So that these waveforms are said to be out of phase. Next one is average value. The arithmetical average of alternating quantity over a one cycle is called average value. The arithmetic average of all instantaneous values of alternating quantity is nothing but either a voltage or current over a one cycle is called average value. So average value can be calculated either graphical method or analytical method. From the below figure, we can calculate the average value by using graphical method. Let us divide the positive half cycle. Let us divide the positive half cycle in a number of equal parts. Why? Because we are taking positive half cycle means the average value should be calculated for symmetric waveform half cycle only. For unsymmetric waveform full cycle. If you calculate average value for full cycle means for symmetric waveform these are the positive values. These are the negative values. So positive values and negative values will get cancelled. So that for symmetric waveform, average value should be calculated for half cycle only. So this is nothing but area under one alternation. Area under one alternation. One positive half cycle is nothing but alternation. One alternation divided by base length. So I1, I2, I3 and so on In. This is the I1, I2, I3, I4. So divide the n number of equal parts of positive half cycle. Then small I1, I2, I3, I4 and so on In are the mid ordinates of the positive half cycle. Then mean of this I1, I2, I3 equals to I average is nothing but I1 plus I2 plus and so on plus In divided by n number of equal parts. This is the graphical method. Whereas analytical method, for the function I of t or V of t equals to area under one alternation from integral 0 to t if it is current signal IDT, if it is voltage signal VDT divided by base length time period t. In this way, we can calculate the average value. So average value equals to arithmetic average of all instantaneous values of current or voltage over a one cycle is called average value. For symmetric waveform, it should be calculated for half cycle only. For unsymmetric waveform, it should be calculated for full cycle. Next one, RMS value is nothing but root mean square or effective value. The RMS value of alternating quantity is defined as square root of average of squares of instantaneous values for a one cycle. Square root of average of squares of instantaneous values over a one cycle is nothing but root mean square or effective value. It is also defined as the effective or RMS value of alternating quantity is defined as the steady current or DC current which when flowing through a given resistance for a given time produces the same amount of heat as produced by the alternating current when flowing through the same resistance for the same time. That means heat produced by DC current equals to heat produced to by AC current. So same resistance for a same time is excited by DC supply. That must be heat will be developed. That must be equal to heat produced by the AC current. Same resistance for same time the heat developed by AC supply. So heat produced by DC current equals to heat produced by AC current. So in order to equating the heat produced by DC and heat produced by AC, we can increase the AC voltage or AC voltage in order to equating the heat produced by DC current. Heat produced by DC current is higher than that of heat produced by AC current. RMS value can be also calculated using either graphical method or analytical method. So it name itself, it indicates root mean square or analytical method, square root of 1 by 2 into integral 0 to t I square into dt, where I is the RMS value of alternating current, I is the instantaneous value of alternating current, t is the time period. So RMS value can be calculated for symmetric waveform, full cycle or half cycle. If it is unsymmetrical waveform, we should calculate the entire cycle only. Next one is peak factor of alternating quantity. Peak factor of alternating quantity is defined as the ratio of its maximum value to RMS value. Ratio of its maximum value to RMS value. Similarly, form factor. Form factor is also defined as ratio of RMS value to average value. These are the basic properties or basic definitions or basic terminology used in AC circuits. Next class, next video, we will discuss about what is the average value or RMS value of sinusoidal signal.